So the first thing you have to check the device link after communicating with the CMC, and it will show you the type of connection here between two brackets. Now I am connecting with a USB printer cable or type P port, so it will give me an indication for the USB. If you are communicating with the Ethernet, it will be ETH here in the device link. And if you have Test Universe 4.40 or later version, you have to open the new test document, and after that you have to specify which test set from the hardware configuration. As you can see, you have to specify here from the test set. And now we are communicating with the 356, and then you can press OK. Then you have to configure how many channel of voltage and how many channel of current you need for this type of test. Now we are configuring 3 current only for the overcurrent and the earth fault protection, and it will appear here in the analog output, as you can see, IL1, IL2, IL3. And for the binary, I configured the binary input 1 for start and the binary input 2 for trip, and both of them is dry, so we can put in the same pair of the binary input. Then you have to press OK. And following our Omicron Ohm's law, you have to start with the test object. As you can see here, this is a new test document, but if you have a PTL, you will find all the review file for the overcurrent and the many more application. So first thing, you have to double click to the device and name the test set and the protection device. As you can see here, the device type, the device address, the serial number if you have, and any additional information like tested by and put your name, and witnessed by, put the consultant name and the substation name, bay name, and all of these fields is mandatory for the test report printing out. So if you don't need, no problem, it's not urgent, just you have to put the required information to be printed out in your test report. And here, as we explained yesterday, you have to specify the nominal frequency, nominal voltage, and nominal current. And then you have, if you have residual voltage and residual current, you have to activate the instrument transformer for the neutral CT or the neutral VT. And here also the number of phases, as you can see, for the railway system you have to check the 2 phases, but for the normal power system protection you have to check the 3-phase protection mode. And as we explained yesterday, the overload detection sensitivity and the debounce and deglitch filter for the electromechanical relay and the dropout time. And here is the most important thing, which is the limit. So here is the limit, which is the maximum voltage is 200 voltage line to line, and the maximum current is 50 ampere. And make sure to read the relay, the protection relay manual to in the part of the technical specification to make sure what is the maximum current the relay can withstand or the analog channel can withstand, and also the maximum voltage to protect your test object. Okay, this is the first part. Then now we are going to add a review file for the overcurrent module. So I will press add function, and I will choose the overcurrent, as you can see. Then you can double click the overcurrent, it will open like this. And here you have to specify the relay behavior. Is it the direction overcurrent or direction earth fault or non-direction? If you choose the directional mode, you have to specify the VT connection start point, the VT connection, and the CT start point. Here is the VT connection. We add the protected object or not add the protected object. Protected object here is the line or the feeder. So if you choose the protected object, means that the VT is on the line, which is the most common cases, by the way. And if you specify not add protected object, this means the VT is connected to the bus bar. Okay, and this is the impact of this VT connection is that if you have a post-fault stage and the VT on the bus bar, it means that when the relay tripping, the bus bar voltage is still healthy. So the CMC will simulate and will inject the voltage in the post-fault stage. But if you choose at the protected line, so if the line is protected and if the line is tripped, so there is no voltage in the post-fault because the line is tripped already. So the CMC will cut the injection in the post-fault stage. And here is the impact of this selection. Then the CT start point, you have to specify the start point grounding of the CT. It is towards the object or to, from the protected object. From the protected object means the CT start point is towards the bus bar. In the most common cases, it should be towards the object. Okay, and this will affect the polarity of the CT and the directional of the current, of the fault current. And here you have to specify also the tolerance in a relative and absolute. We have 2 kinds of tolerance here, relative and absolute. One of them for current and the other is for time. And the test universe automatically will choose whichever is greater. If you don't know, just it will, you can get this information from the technical specification in the protection relay manual. Then you have to go to the element part As you can see here, we have as a default definite time open here, so we can specify and configure this element 1, and also you can rename this element 1, so I can put it OverCurrent I greeter, as you can see. And here, to change the tripping characteristic, you have to press this 3 dot. So let us start with the IEC normal inverse as a stage 1, and then we will add one more stage for the stage 2. And as you can see here from the characteristic definition, you will see the formula used to calculate the tripping time in this characteristic. Okay, and here is the amount and the values of the constant in the equation. Then you can press select. Okay, after that you have to specify the backup current and the TMS in case of inverse characteristic, or the time delay in case of definite time characteristic. So how to specify these values? You can specify from here. As you can see, here is the I pickup is 1 I reference, which means 1 I nominal. So if the current in the secondary, if the nominal current in the secondary is 1 ampere, so here the setting will be 1 ampere. Okay, so this is a relative value, and here is the time index, which is the time multiplier. If you choose this one to be a definite time, you will find this time index is a time delay per second. Okay, so it's absolute value. Now we have IEC normal inverse, so this one is a time multiplier. We can put it as 0.2. Then you can see the characteristic from the right screen here, as you can see, and you can define the directional behavior if you are choosing here directional. But if you choose the non-directional, you will find there is no tab here for defining the relay characteristic angle or the maximum torque angle. Then you can view the resulting characteristic. As you can see here, the pickup is 1 ampere and the TMS is 0.2. Then I will go back and I will add one more element. And this element, I will rename it I double greeter. Then I need this element to be a definite time, so you can check from here definite time, and it will give you the shape of the chosen characteristic from the right screen. Then you press select, and here you have to define again the backup current. Let us make it 3 ampere. And here is the trip time in seconds. Now there is no time index, there is no time multiplier because it's a definite time characteristic. So we have to specify the tripping time, and we can put it 100 milliseconds. Here is the range limit. If you can see, you can make it active or inactive if you have a limit for the maximum fault current and the minimum fault current. If you don't have and you don't need to measure this amount, this values, just untick this active mode. And here is the reset characteristic to define the reset characteristic and the reset ratio regarding the backup value. Then after you finish, you can show show your resulting characteristic. As you can see here, now we have IDMT. First stage is inverse, normal inverse IEC standard, and the second stage is the definite time. Then you can press OK. After you finish this configuration, you have to press OK, and following our Omicron Ohm's law, you have to define the hardware configuration and how many channel of current and the binary input required to check the start and the trip or the backup drop off and the tripping time. And also you have to specify the configuration of this input. Is it dry or wet? Then the third part, to insert the test module. So I will choose test module now to be OverCurrent module. Okay, you can rename it by right click and properties, and also you can open it by double click to see the dedicated OverCurrent module. As you can see from the screen, here we have the characteristic, the inverse and the definite time characteristic, and you can see from here we have the backup and drop off test. We can add points here, as you can see, so it will check the backup and the drop off for the first stage only. In case if you need to check the backup and the drop off for the second stage, you can use the pulse ramping module as we explained yesterday. And here you have to define the fault type. Is it line to line, line to earth, or 3 line? So if you have overcurrent and earth fault available inside the protection relay and it's enabled, so you can use line to line and 3 line to check the overcurrent module, and line to earth to check the earth fault protection. As you can see here, if you have angle also. In case of you testing directional mode, you have to specify this angle to be in the forward mode and to give you the tripping time. And here is the resolution, as you can see. So the resolution now is 50 millisecond. And here is the nominal pickup and the drop off. And here is the reset ratio, which divides the drop off value over the pickup value, and it will give you the reset ratio. And we have a nominal reset ratio now 95%. Then after the pickup and the drop off test, you can add some point to check the tripping time of the characteristic. And here you can add multiple points if you need. So you can add like L1, L2, L2, L3, L3, L1, and also L1, L2, L3 to check the overcurrent pickup for the first stage. Then you can go to the characteristic, and here you can add some point by the cursor. As you can see here, you can move this cursor and press add. Then you have to specify this point. This test point is relative to I greater or I double greater. As you can see now, we are checking the I greater, so you can choose this one, and also you can choose different fault types, as you can see from here. And here is the factor, which is multiplied by the setting available in the review file. So if you multiply 1.25 by 1, it will give you 1.215 ampere. And here is the angle in case of directional overcurrent, and here is the T nominal expected at this time, and this nominal tripping time is calculated from the formula of the IEC standard inverse. Then you can add many points, and you can add different fault type, as you can see, or you can add a multiple. Multiple means you will add a lot of test point in this range. So if you press this one, I can choose I greater, and I will start from 1.2 up to 3, and the step size you have to identify to be like 100 milliamp or 200 milliamp. So I can choose 300 milliamp, and here it will give you the step count and the number of steps to check this type of multiple shots. And after that, you have to specify which fault current and which fault type you have to add it. So I can choose L1, L2, L3, and I can choose all kind of line to line. So it will be added automatically, as you can see. So I have here this point 1.2, 1.5, 1.8, because I defined the step size 300 milliamp. Okay, then I will add multiple test shots for the definite time, but here I will choose I double greater, and because of the definite time is at 3 amp, so I can start with 3.5 up to 6, for example, and I will define the step size also to be 500 milliamp. So I will have 6 steps in this multiple shots. Here also you have to define the fault type, so I can define L1, L2, L3, or as you need from here. So the total shot count will be 6. Then you can press OK. So this is the test shots for the I double greater, as you can see from here, and the nominal trip time for this shots for the I double greater stage, it will be 100 milliseconds, because this one is a definite time. Okay, and the T minimum and T maximum is getting from the review file, and the percentage, relative tolerance and absolute tolerance, whichever is greater. But for the first stage is depending on the current. So once the current is high, the trip time being low, because this is inverse characteristic and inverse relationship between the current and the tripping time. Then you can start here, but you have to define first the trigger option. So now we are defining the trip contact to check the tripping time, and here is the one, which means it's normally open in the dead status, and it will switch to closed status. And here is the start condition. Now you have two options. You can select the fault inception or the starting contact. The starting contact is more accurate than the fault inception, as the CMC will take the backup the backup signal, and it will initiate the timer until the tripping command is getting, so it will give you more accurate result. If you don't have a start signal from the rotation relay to simulate the backup, you can choose the fault inception as default, but in this case, you have to add in your mind the minimum tripping time for the rotation relay, which is around 20 to 25 milliseconds. Okay. Then we have also another tab for the setting. As you can see, here is the load setting. Here you can simulate a pre-fault before each shot and before the starting the fault state, it will simulate a pre-fault current, because some protection relay needs a pre-fault before tripping and before getting to the fault condition. And here we have also the time setting. We have a pre-fault time. If you specify the load current, it will be injected in this pre-fault time. And we have also the post-fault time, 500 milliseconds, to allow the relay to go for the reset status after each shot. And we have also absolute maximum time, which is defined here 240 seconds in absolute, and maximum time 100% from the expected tripping time. Which means if I'm expecting 1 second, so the maximum time it will be 2 seconds. Okay, so after 2 seconds, it will, if there is no tripping command coming at this 2 seconds, it will shift to the next shot, and it will detect that this test shot is failed because there is no tripping time and there is no tripping contact received. Okay, so whichever is faster, the absolute maximum time or the relative maximum time, it will taken as the maximum testing time for each shot. Okay, so make sure to define the maximum test time to be more than the slowest tripping time you are expecting. So if the slowest tripping time is 10 seconds or 20 seconds, this maximum testing time should be greater than this 20 seconds to allow the CMC to detect the feedback and to be long enough to get any feedback from the protection relay and assess the test result. Then we have also a voltage setting. If in case of you are enabling the directional mode, you have to enable this option, and it will take directly the nominal voltage in line to line and nominal voltage in line to neutral. Sorry, I have a lot of messages. And here is a decaying DC, and this one allows you to inject a more realistic fault, because we, as you can know, we have a DC component in transient signals. It happens in the fault conditions. So if you have arc resistance or if you have a DC component, the CMC will simulate a superimposed DC waveform to the fundamental waveform to give you a more realistic behavior from the protection relay. Okay. Then we have the CP characteristic. As you can see, here is the minimum time or the minimum tripping time of circuit breaker is 50 milliseconds. And if you can see, it's a purple color, which means it's connected and linked to a value. And if you go to the link to X-ray, you will find this is linked to the CP configuration and the minimum circuit breaker tripping time, as you can see. So by default, it's linked to the CP configuration tripping time. And here is the thermal image. If you need to check the thermal image or the thermal overload reset for the overcurrent protection, you can enable this reset. Otherwise, you can keep it as default. For the binary output, there is no need for any binary output in this case, because you are testing the overcurrent and earth fault. But in some cases, like switch on to fault and many more applications like distance characteristic, you can simulate any kind of binary output to be connected to the relay binary input to simulate this kind of scenario. Okay. Now you are ready, and you can start the characteristic in the offline mode or the online mode. So we will check now the relay setting, and we will export the relay setting in X-ray file. Then we can import it inside the PTL. Then we can start to practical session to detect this tripping types. Okay, now we are going to the practical part. So you can add some points for the pickup and the drop-off test, as we explained. So I added 4 points here for checking the line-to-line and 3-line pickup test for the overcurrent stage 1, as you can see, which is expected to be 1 ampere, and it will check the pickup actual time and the pickup actual current and the drop-off current, and it will give you also the reset ratio for the drop-off over the pickup value. And here is the characteristic test. We add multiple test shots for checking the I greater and the I double greater, as you can see from this screen. So because it's inverse characteristic between the current and the time, so if the current is higher, so the time is less, and you can check here from the nominal tripping time for each fault type. Then you can add also multiple test shots for the definite time, as you can see here, and the expected nominal time, it will be definite as 100 milliseconds. At that case, it will take the absolute tolerance into consideration, because this one is the greatest one, more than the relative tolerance. And then you have to define if you need to inject a load current as a pre-fault current for 100 milliseconds, which is a pre-fault time, or no need, because some of protection relay require a pre-fault current before going to the tripping states. And here also you have to define the absolute maximum time and the relative maximum time as we agreed. And here you have to define also the trigger condition to be with the trip contact, and no need to activate the start contact, because once you configure the start contact for the binary input 1, so for the pickup and the drop off test, the CMC will take this start contact as trigger condition for the pickup and the drop off test. So just you have to configure the trip contact to get the trip command, and then you can define the start condition to be the fault inception or the starting, and there is no need for the binary output in that case. And then you can go to the test value again, and you can inject. And from here, from the right, you can see the report view to be printed out in your test report, and you can define this report to add some characteristic, for example, and to remove some details if no needed in your test report. Then we have also the time signal view, which give you the start and the trip condition for each test shot, as you can see. And also we have the phasor view, which gives you the L1, L3. For example, now we are expecting the L1 and the L3 only because this is a line to line. But if you select the line 1, line 2, line 3, you can see it in the phasor view. Then you can go to the report view, and you can start to check the tripping time and the pickup and the drop off values. As you can see, here is the actual pickup current, and here is the actual drop off current, and the reset ratio is being calculated based on these two measured values. Now the characteristic test, as you can see, this green plus, it means that the test shot is passed. And if you need more information about the tripping time, you can see here the actual tripping time compared to the nominal tripping time, and what is the deviation, and if this test is assessed pass or fail. So you have to check the relay technical specification, or if you are using the BTL, it's included already based on the relay manual. So the BTL, no need to double check; it will be available, and it's matched with the type of protection relay. So as you can see here from the report view, if you expand this report view, it will give you the test result and the deviation, which is the percentage error, and it's passed or failed. But if I need to add some characteristic to the report to be printed out, I can choose here from the test result, and I will activate the characteristic diagram, and I can remove the setting and the test module to be more compact. Then you can click apply, and as you can see now, you have the general stages, stage 1 and stage 2 with the setting. Then you have the table for the shot test result, so checking the tripping time of the characteristic with the different fault types for both stage, and the pickup and the drop off result. And you can see here the characteristic for stage 1 and for stage 2. Okay. Now, if you are, if you need to check the pickup and the drop off of the second stage, which is a definite time, you have to insert a pulse ramping module. So if you double click the pulse ramping module, will allow you to identify the start and the stop value based on the setting. So from 80% up to 120% from the nominal setting, which is 3 ampere. And also you have to define the delta, which is the step size, the pre-fault time, the reset time, and the fault time. And if you decrease the delta, it will be more accurate for your test, but it will increase the maximum duration and the number of steps. As you can see now, it's changed from 25 to 61, and the maximum duration is from 12 seconds to be 30 seconds because I increased the step size. And if you see the phasor diagram here, it will be more having 61 pulse for checking this kind of pickup and drop off for second stage. And here you have to define also the trip contact, which is switching from 0 to 1, and specify the nominal current and the tolerance, as you can see here, and then it will give you the actual tripping time, and based on this tolerance it will give you also the assessment as you can see. If you choose the relative, it will give you the tolerance in percentage, and if you unactivate this, it will give you as absolute value. You can link this value also to the stage 2 overcurrent pickup. As you can see here, we have overcurrent elements, overcurrent element 2, and we have a pickup current, and here is a nominal which is 3 amp. So you can link it automatically to if the setting is changed, it will be adapted automatically to the new setting. No need to start from scratch. And the most important thing here in pulse ramping, to define the fault time to be long enough to check the definite time stage, but not long enough to interfere with the first stage. Okay, so 200 millisecond is more than 100 millisecond, and it's enough and doesn't interfere with the stage 1 tripping time. Then you can press start after defining the trigger condition. You can see here the pulses. So each one is a pulse, and so set, reset with a step size 20 milliamp. And for the result, it will be written here in the actual result. So it's 3.020, which is a division 20 milliamp. So it's very good to check, and you can rename this one to be I double greater pickup and drop off. Okay. Now we finished the overcurrent module with the pickup and drop and characteristic test shots.